Okay, so we've got the reactivity of some metals being investigated, and they're telling us that each metal was placed in a separate um, container of dilute hydrochloric acid, and the amount of effervescence. Now remember, effervescence means fizzing, and the amount of effervescence was observed. The same mass of metal was used in each experiment. Which piece of apparatus would be used to find the mass? So to find the mass, we would use a balance to weigh the metal. Okay, two variables of part mass would keep the same. So if we're going to do this experiment, we're going to have to control the concentration of the acid, and we're also going to have to control the surface area of the metal. Okay, so you could have a piece of copper and its little sheet and you drop it in, or you could have filings of copper and the filings have a large surface area and therefore affect the rate of reaction. So the two things I've identified is the concentration of the acid and then the surface area of the metal that's being dropped in. Magnesium produces the most vigorous effervescence, that means it's reacting more. Copper does not produce any. Give a reason copper does not produce any, so copper is not reactive in the acid. Okay, the magnesium reacts with dilute hydrochloric acid to form magnesium chloride solution. Now here they're helping us out, they're telling me this is a solution and it tells me hydrogen gas. Fill in the missing state symbols. So the state symbol for a solution is AQ and the state symbol for the gas is AG. Potassium carbonate reacts. Potassium sulfate contains potassium ions and sulfate ions. Work out the formula. So the way we do this is we've got a K plus ion. So because it's plus one, it wants to make one bond. And then we've got a sulfate, which is a 2 minus ion, which means it wants to make two bonds. So we cross these over. So K gets the 2 and the SO4 gets the number 1. So I need to write that down. So my formula is K2SO4. Okay, so it says equal volumes of a solution were reacted with an excess of sulfuric acid. Pure dry samples of the potassium sulfate were obtained, and here are the results from the 3 experiments. Calculate the mean mass of potassium sulfate. Give my answer to, and watch out for this, give my answer to 2 decimal places, okay? So the first thing I'm going to do is check, and all 3 answers here are close together. So I don't have a piece of data I'm going to leave out because it's anomalous. I'm going to keep it all in. So all I need to do is add these together. I'm going to show my working out. So there's my 3 numbers. And then I divide by 3 to get the average. So let's just test that. So it's 5.22 plus 5.24 plus 5.21. Okay. And then I'm going to divide that by 3. And that's given me an answer on my calculator of 5.223. And I'm going to don't throw any more down there because 2 decimal places. So I've got the first decimal place, second decimal place, third decimal place. This one here is less than 5, so I don't need to do anything. So my answer is going to be equals 5.22 to 2 decimal places.